In this video, I just wanted to talk a little bit about the graphs of sine and cosine, which is the main focus of this module. And so I want to show the connection between what we've done already. And what we've done already is talk about how we can find the values of sine and cosine by either right triangles or the unit circle. And here we've got the unit circle. So I'm going to press play here, and if you rotate around, those points on that unit circle, we can express them as a value of sine or cosine. If you paused it anywhere, we could draw a right triangle in there and use the right triangle instead to find the value. So how does this relate with the graph of sine and cosine? Well, what we actually start doing is, instead of just thinking about going around and around in a circle, the angle value is actually now going to be graphed along that x-axis. So let me kind of show you what that might look like. I'm going to press play again. So now if I instead take the angles, let me pause right here, for example. So if you notice on the unit circle, we're talking about an angle rotation of 180 degrees or pi. And I want you to notice that the x value, where the green dot is also at pi. The y value is 0, and that's because sine of pi is equal to 0. So the output in that case is 0. Let me go a little bit more here and try to stop halfway. Oops, right about here. So again, if we think about the unit circle, now we're talking about 3 pi over 2 radians, or 270 degrees. So again, if we look at where that green dot is, the x value is at 3 pi over 2, but now the y value of that green dot is -1. And that's because sine of 3 pi over 2 is -1. And let's keep going. And let me pause again here. We're kind of at now the angle 2 pi. Sine of 2 pi is 0, and so that's what the graph looks like. So what we're mostly graphing when we're doing sines and cosines is what we would consider one cycle or one period, which for the sine graph, this is the basic graph of the sine function. It starts at 0, then it goes up to 1, it comes back to 0 at pi, it's -1, and then it's back to 0 at 2 pi again. So typically we're going to graph it like this, but it actually keeps repeating because we could go around the unit circle again. So I'm going to press play to kind of show that. So if we kept going, it's just going to keep that exact same pattern going over and over again in the left and right directions. Okay, let me pause it again. And now let's switch to cosine. So let's do the same thing. I'm going to press play again here. And I didn't stop here, but let me stop here this time. Is cosine of 0 is 1, and that's why the first part of the purple line starts at 0, 1. And then at pi over 2, cosine of pi over 2 is 0. So that's why the purple line right now is at pi over 2 for the x value and 0 for the y value. Let me keep going. At -pi, cosine is -1. I'm sorry, at pi. I feel like I can't think as fast as this is going. Cosine of pi is -1, and then cosine of 3 pi over 2 is 0, and then if we keep going here, pause, cosine of 2 pi is 1 again. So this is the basic graph of cosine. And maybe to kind of make that clearer, I'll actually take out the unit circle. So this is what cosine looks like. So quite similar to sine, but we're actually starting in a different spot. So what I typically try to remember is that whenever we're doing the sine, it starts at the y is equal to 0. Whenever you're doing cosine, it makes a little bit of a U shape because it starts at +1 for the y value. If we keep going, it just keeps repeating, and then it starts to look a little more like the sine graph, which is just a wave here. And then it repeats like this all the way to the left and to the right. Okay, so now I would just like to write a little bit about this to help you get started. So whenever we graph these sines and cosines functions, usually we talk about the key values. So what I'm going to do And one thing I mentioned before is I typically always use right triangles when I'm doing trig, except for when I'm dealing with these 90-degree angles. That's when I tend to use the unit circle, so that's what I'm going to do now. So if we've got our unit circle, here, it's kind of like a circle, I guess. Let me write all of these values. And so now I'm going to write them as our angle here, and then let's do sine of theta first. So when the angle is 0, sine is going to be the y value here, so that's 0. When the angle is pi over 2, sine is 1. For pi, sine is 0. For 3 pi over 2, it's negative 1, and then I'm going to go back to 2 pi, and it's 0 again. So this is where I was getting all of my sine values from. And these are considered, when you hear in any videos or the textbook when they talk about the 5 key values, this is what it's referring to. So we've already kind of talked about that. What we're doing now is really just writing them as ordered pairs on a graph, where this is representing the x now, and that's representing the y. So for these graphs, the x is actually representing the angle. So now when I go ahead to graph it, I've got my x, and then I've got my y. And then you'll see as you work on this section this idea of amplitude, but without the amplitude it's just always going to go between a positive 1 and a negative 1. And I know my graph is going to be, it's going to go up and down in between the 1 and negative 1. So let me start with the point 0, 0 would be right here. And then actually before I do that, I'm going to make a couple tallies here. So the 5 key values, it's going to be at 0, and then I've got, that's 1, 2, 3, 4, 5. The 5 key values are kind of referring to those tallies on the x line. All right, so we've got 0, 0, pi over 2, and 1. I guess I should go ahead and fill that in, pi over 2, pi, 3 pi over 2, and 2 pi. And then pi 0, 3 pi over 2, and negative 1, and 2 pi and 0. So 5 key values, I put those points down, and then the graph is going to have a curved shape like this. So this is the graph of sine of x. So that's the main graph of sine of x that I want you to be familiar with, knowing that it comes from these same points from the unit circle that we've already talked about. And then once you feel comfortable with that, what we are going to do is we are going to do transformations with the sine of x graph. And if you've recently taken college algebra, you might be familiar with transformations, and it's the same type of transformations that we're going to use for the trig functions as well. And let me go ahead and do the same thing with the cosine graph. Now let's try the same thing with cosine instead. So I've left a lot in place because our angle values or x values are not going to change. But now since we're dealing with cosine, to find what cosine of 0 or cosine of pi over 2 is, we're going to use these values from the unit circle. So cosine of 0 is 1, so we have the point 0, 1. Cosine of pi over 2 is 0, so we've got pi over 2, 0. Cosine of pi is negative 1, so we've got pi negative 1. Cosine of 3 pi over 2 is 0 again. So put 0 there. And then finally 2 pi, we're back to 1. So 2 pi and 1. So let me plot these points now on our new xy plane here. So 0, 1 gets us to this first point, right, starting at 1 instead of starting at 0. Then 0, then -1, 0, and then +1. So it should look like a V when we graph the cosine, but we know that the shape is not a V. It's going to have a more curved shape to it. So when we graph it, we want to make sure to draw it like that. So this is the graph of cosine. Y is equal to cosine of x. So hopefully that helps you get started with the section for this week.